बिस्मिल्लाहिर्रहमानिर्रहीम सल्लल्लाहु अलैहि वसल्लम अल्लाहुम्मा रब्बि ज़िदनी इल्मा सल्लल्लाहु अलैहि वसल्लम आमीन अल्हम्दुलिल्लाहि रब्बिल आलमीन। Integration. The topic of this lecture is the important concepts of integration. For this lecture, I am using the work of one of my most dedicated and hardworking student, Miss Safai Idris, of class 2020, the Lyceum. This is the list of important questions of this chapter from my practice book. Integration. Integration is the reverse process of differentiation. This is the sign of integral, and this is the integral operator, and they both come together. This object is used to integrate the given polynomials. The word integrate means use this to integrate the given polynomials. Example, integrate this polynomial. To integrate this polynomial, write this polynomial between the sign of integral and integral operator. This word integrate means write this polynomial between the sign of integral and dx. And bracket is compulsory. Write the polynomial in the bracket because this sign of integral is multiplying with both the terms and this operator is multiplying with both the terms. So bracket is compulsory. And remember, for two or more terms, always use bracket. When you integrate constant, you write x with the constant. So this 5 will become 5x. And this minus 3x will become minus 3x power 2 over 2 because we add 1 in power and we divide the term by the resultant power. This x has power 1. So when you add 1 in this power, this will become 2. And 2 must be here because we divide the term by the resultant power. And this is the constant of integration. Since this integration is without the limits, means indefinite integration, therefore we always write constant when we integrate the function or polynomial. Integration of simple algebraic functions. This is the simple algebraic function. So when you integrate this x power n, it will become x power n plus 1. And you need to divide this term by the resultant power, which is n plus 1. So when you integrate anything, you add 1 in power. Anything means simple algebraic functions. When you integrate any simple algebraic function, you need to add 1 in power and divide the term by the resultant power. The resultant power is n plus 1, so divide x n power plus 1 by n plus 1. And write the constant of integration because this is the indefinite integration. And this formula is true for all values of n except minus 1. Minus 1 is not in the syllabus. Well, since we don't have anything between these two, so the answer is x. And the logic is when we don't have anything, we have x power 0. So when you add 1 in power, it will become x power 1 over 1. This is the logic. X power 0 dx. When you integrate this, this will become 0 plus 1, 0 plus 1. That will become just x. It's here. So when we don't have anything, write x here. Since the operator is of x, like dx, so write x. What if we had dy? Then write y. This is the constant. So constant means like this, 5x power 0. So when you will integrate 5x power 0, it will become 5x power 1 over 1 plus c. It's here. So when we have constant, write 5x because operator is x. So 5x. This is just x, so it will become x power 2 over 2. Well, when we integrate fractions like this fraction, So we first bring variable in numerator. We only bring the variable, we never bring the coefficient. We leave the coefficient as it is. So just bring this x power 2 in numerator and then integrate it. So when you will bring this in numerator, this will become 3 upon 2 x power minus 2. When you will integrate minus 2 x minus 2, it will become minus 2 plus 1 minus 2 plus 1, that will become minus 1 upon x. So the final answer is minus 3 upon 2x. Well, here you need to break the LCM. So when you will break the LCM, then you'll get this thing, 5x square upon 3x square and 2 upon 3x square. Make sure you will use bracket for 2 or more terms. Always use bracket when you have 2 or more terms, because this sign of integral is for both the terms and this dx is multiplying with both the terms. So bracket is compulsory. This is the simplified form of this term and this is the simplified form of this term. Well, when you will integrate 5 upon 3, it will become 5 upon 3 times x, because this is the constant. When you integrate constant, you always multiply constant with the x, variable x. And the integration of this will become 2 upon 3 x negative. Because x power minus 2 will become minus 2 plus 1, minus 2 plus 1. And the simplified form of this will be minus 1 upon x. The integration of 1 will be x and the integration of 3x will be 3x power 2 over 2, because this x has power 1. So when you will integrate x power 1, it will become x power 2 over 2. Again this 1 will become x and this will become 3x cube over 3, and the simplified form will be x plus x cube plus c. Now the next topic is integration of non-linear expansions. This is very important, the non-linear expansions. Whenever you integrate non-linear expansions, always expand the expansion first and then integrate it. First expand the expansion, simplify it and then integrate it. So this is the non-linear expansion. This function is non-linear. First you need to expand it, simplify it and then integrate it. This is the expanded form of this expansion. Now you can integrate this. 1 will become x, this will become 4x cube over 3 and this will become 4x power 5 over 5. Logic, why do we expand the expansions? Because the differential of non-linear expansions is variable and we can never divide expansion by the variable differential. Here is the logic. The differential of non-linear expansion is variable. Never divide equation by variable. This is an example of non-linear expansion. This is a non-linear expansion. So first expand this expansion and then integrate it. This is the expanded form. Whenever you will get non-linear expansion, the power of the expansion will always be 2. This is in the syllabus. You won't get power 3. Normally they don't give power 3. They always give expansion with power 2. What if power 3 is given? Then you can easily expand power 3 like this. First write power 2 and then write power 1 and then expand this and then multiply this and then you can easily integrate this. But power 3 never came in these questions of past papers. So first you need to expand this and then integrate this. X power 4 will become x power 5 over 5. This will become 4x power 4 over 4 and this will become 4x cube over 3, and this is the simplified form. And write constant of integration whenever you integrate the indefinite integrals. Integration of composite linear algebraic functions. Algebraic expansions, you can say. This is the linear equation. and this is the linear expansion. So whenever you have to integrate linear expansion, you can integrate the expansion directly without expanding the expansion. You don't need to expand the expansion. You can just add 1 in power, divide the expansion by the resultant power, and multiply this resultant power with the differential of this expansion. The differential of this expansion is A. When you differentiate this thing without bracket, you will get A. So the rule is add 1 in power, divide the expansion by the resultant power, and multiply this resultant power by the differential of this expansion. This is the formula of the integration of composite linear algebraic expansions. Examples. This is the linear expansion. So you just need to add 1 in power, divide the expansion by the resultant power, and multiply this resultant power with the differential of this expansion. The differential of this expansion is -3. So you need to multiply half with -3. And when you add 1 in half, negative half, you'll get positive half. And this is the simplified form of this uh, expansion. Well, this is again a linear expansion. So you just need to add 1 in power, divide this expansion by the resultant power, which is here, and multiply this resultant power with the differential of this bracket. The differential of this bracket is -3. So -3 is here. Since the expansions, this expansion is linear, so you don't need to expand it. You can directly integrate this expansion. We only expand the expansion when the expansion is a non-linear expansion. Since this expansion is a non-linear expansion, therefore first expanded and then integrated, because its differential is variable and we can never divide function by variable differential. So whenever we have non-linear expansion, always expand the expansion first and then integrate it. This is the expanded form. We use a minus b whole square here, and this is the integration of this expansion. So make sure you always integrate, you always first expand the nonlinear expansion and then integrate it. Never integrate the nonlinear expansion with by this rule, because this is the rule for linear expansions only. This is the wrong method. Since the expansion is non-linear, so you cannot use the rule of the linear expansions over here. You cannot add 1 in power, you cannot do this thing. See, the differential is variable, and we can never divide expansion by variable differentials. Therefore, we cannot use the rule of linear expansion over here. We always expand this expansion first and then we can integrate it. Well, the next topic is equation of the curve from the gradient. This is the gradient. When you integrate the gradient, you get equation of the curve. This is the general equation of the curve. You all know when you differentiate y, you get dy upon dx. So when you will integrate dy upon dx, you will get y. This is the differentiation and this is the integration. That is why integration is known as the reverse process of differentiation. Example. Given that dy upon dx is this at this point, the question is find the equation of the curve. It's very simple. You just need to integrate dy upon dx. When you will integrate this dy upon dx, you will get y. And when you will integrate this 6x power minus 2, it will become 6x power minus 1 divided by minus 1 plus c. Now get the simplified form of this and then substitute this point into this equation, into the simplified equation. You can substitute this here. By substituting 2 and 9 here, we have c, which is 12. Now substitute 12 here. This is the equation of the curve. So first integrate the gradient and then use the given point to get the value of c, and then substitute c back into the equation and get the final answer. Well, this is the next topic, equation of the curve from the second derivative. So if you are going to find equation of the curve from the second derivative, you need to integrate the second derivative twice. So make sure you integrate the second derivative twice. This is the example. This is the second derivative and this is the turning point. Turning point means a stationary point, or turning point means gradient is 0 at this particular value of x. With the help of this condition, we will find the value of this c. So since we have second derivative, so we have to integrate the second derivative twice to get the equation of the curve. This is the first time we integrated this. When you will integrate second derivative at the first time, you will get first derivative. And this is the integration of this function. Now use this information and get the value of c. When you will substitute this information into this equation, you will get this value of c. Now substitute this c back into this equation. This is the simplified form of the first derivative. Now integrate first derivative again to get the equation of y. You just need to integrate first derivative to get the equation of the curve. So this is the integrated form of the first derivative. Now use this information 3 minus 10 here in this equation to get the value of d. When you will use this information, you will get this value of d. Now substitute d here to get the final answer. This is the equation of the curve. So it's simple. Whenever we have second derivative, integrate the second derivative twice to get the equation of the curve. When you will integrate the second derivative at the first time, you will get the first derivative, and then when you will integrate the first derivative, you will get the equation of the curve. So make sure you integrate the second derivative twice to get the equation of the curve, and make sure you use this condition carefully. Now this is very simple. Second derivative can also be written as f double prime x, and first derivative is f prime x, and equation of curve is f of x. So you need to integrate second derivative twice to get the equation of the curve. Definite integrals. Definite integrals means integrals with limits. This is the lower limit and this is the upper limit. When both the limits are same, then the answer will always be 0. This is the rule number 1 for definite integrals. Rule number 2. When the lower limit is greater than the upper limit, then we always switch the limits by writing negative sign before the sign of integral. Make sure you always switch the limits whenever the lower limit is greater than the upper limit, and make sure you write negative sign while switching the limits. Application of integration. Area. Area between the curve and the x-axis. This is the x-axis. When the curve is above the x-axis, this curve is above the x-axis, and these are the limits. This is the lower limit and this is the upper limit. We need this area. To get this area, we need to integrate this curve from these two limits by using this formula. Write the lower limit here and the upper limit here and use this formula y dx. Well, this area is between the curve and the x-axis. So the formula must be the operator, the integral operator must be of same type of variable. Since the area is between the curve and the x-axis, so the operator should be of x-axis, like dx. I mean, these two variables must be same. This is x-axis, so this must be dx. And these two variables are always opposite. You can easily learn the formula uh, like this. This operator is of the same type of the axis. Since the area is between the curve and x-axis, so this operator should be of dx, like the variable x, and this must be the opposite variable of x, like y. So you can learn this formula in this way. Dx is here and these two are opposite. Well, when the curve is below the x-axis, then you will use the same formula but write negative sign before the sign of integral. Like in this situation, this curve is below the x-axis. You need this area, the area between the curve and the x-axis. So you need to use the same formula but write negative sign before the sign of integral, because this answer will be negative. And this negative will convert this negative answer into positive answer, because area is a positive quantity, a scalar quantity. Since area is a scalar quantity, therefore area can never be negative. So this negative will convert the negative answer into positive answer. So make sure whenever the curve is below the x-axis, always use negative sign before the sign of integral. Area between the curve and the y-axis. This is so simple. Since this curve is on the right side of the y-axis, so this will be the formula. Positive sign before the sign of integral. And since we need area between curve and y-axis, so this should be dy. The integral operator should be dy, and these two variables are always opposite. And this is the lower limit and this is the upper limit. When this curve is on the left side of the y-axis, then the formula will be same, but you need to write negative sign before the sign of integral. Just need to write negative sign and the formula is the same, because this answer will be negative and this negative will convert the negative into positive. Well, when we need area between two curves, if you need area between two curves, then you need to use this formula, like upper curve minus lower curve. This is the upper curve and this is the lower curve. Because when you will integrate the upper curve, you will get this area and this area. You will get all the area between the curve and the x-axis, this total area, when you will integrate the upper curve. Well, when you will integrate the lower curve, you will get this area. Since you need only this area, so you need to subtract this area from this area. I mean, you need to subtract the area of the lower curve from the area of the upper curve, because this area is the larger area and this area is the smaller area. So always write upper curve minus lower curve. This is the upper curve and this is the lower curve. And you can even take common the sign of integral in dx. There are two ways to write this formula. But this one is simple. Always use this formula, because in order to avoid careless mistakes, this formula is better for area between two curves. And you can even use this formula. Well, this is the next application of integration, volume of revolution. When f of x is rotated 360 degree or 2 pi, they both means the same thing, about the x-axis. So a volume will be generated. To get that volume, use this formula. You just need to make few changes in the area formula. Write pi here in the area formula, and in area formula y has power 1. So in volume formula, the power of y must be 2. So If you want to learn this formula, you can just make few changes in the area formula. Just write pi in the area formula and write the power 2 of this variable. This is the formula of volume of revolution of 360 degree about the x-axis of this curve. Same formula is used for above and below the x-axis. Volume is never negative whenever whatever the curve is, like if the curve is below the x-axis, so use the same formula, because volume, we get volume when the curve is rotated 360 degree or 2 pi radians about the x-axis. So the formula will remain same whether the curve is above the x-axis or below the x-axis. When f of x is rotated 360 degree or 2 pi radians about the y-axis. This is the area formula of this area. So if you want to learn the volume formula, it will be very simple. You just need to make few changes in the area formula. You just need to write pi here, and this x will become x square. This is the volume formula when the curve is rotated either 360 degrees or 2 pi radians about the y-axis. Since the curve is rotated about the y-axis, so this operator should be dy. And these two quantities are always different, opposite. These two variables are always opposite. If this is y, this must be x. In volume formula, it is x square. In area formula, it is x. Volume of revolution between two curves or shaded volume. This is so simple. You just need to check the area formula of this area. This is the area formula. Just make few changes in this area formula. Write pi here and write this f of x is f of x power 2. Write pi here and gx will become gx power 2. You can even take common sign of integral. But this will make the calculations very complicated. So I would strongly recommend you all to use this formula. Don't use this formula. This formula will make the calculations very difficult, and in order to avoid careless mistakes, use this formula. Anyway, this is all. I hope this lecture will help you all to understand this topic, the integration, well. Inshallah, I will try my level best to discuss the important questions of differentiation and integration in my next lectures. Allah Hafiz.